In this video, we're going to talk about set unions, intersections, and complements. And what I'm going to do is I'm going to work through an example that's kind of similar to what you see in worksheet 1. So I'm going to think of a set A. My set A is just going to be my family. So it's going to be my parents, my 3 brothers, and my husband. And then I'm going to kind of go through and think about different ways to describe this set. Right, so I've just written it as my family first. So if I want to write it in roster notation, I'm going to actually list out the members of my family. So I'm going to have my dad, my mom, my brothers, Brian, Mark, and Ian, and then my husband, Jimmy. So I'm going to consider those the members of my family. I could also list this out in my set builder notation. So in set builder notation, I would have the set X, where X is a member of, let's say, my immediate family. I'm not including in-laws or aunts and uncles or grandparents. I just have my immediate family here. I can spell. All right. So now we can think about unions and intersections, but we need a couple sets first. So let's think of some subsets of this. So I'll think of B, and maybe this will be the members of my family who are left-handed. All right, my dad and my brother Ian are both left-handed, so I could write this out in roster notation as dad and Ian. And maybe C will be the members of my family who live in California. Family members who live in California. So then my brother Mark and my brother Ian both live in California. So we have Mark and Ian. Okay, so now that we have our sets, we can go through and think about our unions and our intersections, but it might be helpful to first draw a Venn diagram so that we can really picture what's going on. So let's go ahead and do that. So I'm going to think of my set as my family, right, because that was sort of the big set that everything came from. So I'm going to picture this as the universal set. All right, so then that's going to be my U. That's everything in the box. And then I can start putting people in the sets. So we'll have this one be the set B. Let's make this other one another color. Yeah, let's actually keep colors consistent. So this will be set B here. This will be set C here. And then we can put in the members of the family. So my dad, he's in set B, but he's not also in C. So he would be here. My brother Ian, he's in both set B and C. So we got to put him in both sets in the middle there. And then in set C is my brother Mark. Right, Ian's already in that intersection. He's in both of those sets. And then outside of B and C, we have the rest of my family members. So they're neither left-handed nor live in California. So I have Jimmy, I have my mom, and my brother Brian. So they all live in the complement of that union. Okay, so now let's sort of put all these pieces together and think about the unions and the intersections and the complements of these different sets. And we'll do that on the next slide. Okay, so now that we have our sets and our Venn diagram drawn, let's go through and think about some of these unions and intersections and probabilities. So I've just redrawn the sets that we had in the last slide, and we've got our Venn diagram. So now what I want to do is I want to figure out what these different sets are. So the first one is B union C complement. So maybe the first thing we can do here is figure out what C complement is. C complement is going to be all of the things that are not in C. So I'm going to write out the description first. So it's the members of my family. Right, so the complement always has to refer back to some universal set. So we've said here that A is this universal set. So I'm going to only focus on members of my family who don't, right? C is people who live in California, so C complement is the people who don't live in California. Okay, so I'm going to take my family members, I'm going to get rid of the ones who live in California, and be just left with the ones who don't live in California. So my parents, my brother Brian, Mark and Ian do live in California, so they're not in this list, and then we'll have my husband Jimmy. So those are the members of my family, excluding me, who don't live in California. Okay, and now I want to union this with B. So I need to take all of the things that are either in C complement, so the things that aren't in C, and add additionally the things that are in B. So in B, we have my dad, who's already in C complement, so he doesn't get added to that union, and my brother Ian, who wasn't there yet, so I do need to add him in. So that tells me that my B union C complement is going to be the stuff in B, dad, Ian, and then the additional stuff in C complement, my mom, my brother Brian, and Jimmy. So we can build our B union C complement that way. I can also picture it from looking at my Venn diagram, although it's a little difficult because I have to sort of look at more complicated sets. So when I'm looking at C complement, I want to basically get rid of all of the stuff in C. So I'm getting rid of Mark and Ian because they're inside that red circle C, and just focus on the stuff that's left. So you can kind of picture covering over that Mark and Ian set there. So we're not picturing them, and we're just looking about everything that's left. And now when I union that with B, I'm unioning all of the stuff in the blue set. So I add back everything in that blue set. So now I have the stuff that was in B, the blue set, so that's including Ian and Dad, plus the stuff that wasn't in C, so then that's again my dad, Brian, Mom, and Jimmy. So all together, we get that Dad, Ian, Brian, Mom, and Jimmy are in that B union C complement. All right, so let me go ahead and get rid of this rectangle here, and then we can look at the next example. So the next example is B intersect C. So when we think of intersect, we want to think of it as and, but that can get a little confusing sometimes, because I don't want to think of the stuff in B and the stuff in C. I want to think of the stuff in both A and B. Sorry, B and C. So the stuff that is both people who are both left-handed and live in California. So we can see from our Venn diagram that the only person who both lives in California and is left-handed is Ian. So he would be the intersection of those two sets. Okay, the next question asks us to find the probability of B complement. Sorry, I'm going to go back for a second. I want to write out what this actually means, right? So the intersection of these two sets is the people in my family, because it comes from the overall universal set A, who do both B and C. So are left-handed and live in California. Okay, so now let's think about the probability of B complement. First, what is B complement? So B complement is the stuff not in B. So these are the people who aren't left-handed, which we could also write as the people who are right-handed. Okay, so if Mark and Ian, okay, sorry, I was writing in red, but I should be looking at my blue set. So my dad and Ian are left-handed. So everyone who's not left-handed is my mom, my brother Brian, my brother Mark, and Jimmy. So that is my B complement. So to find the probability of B complement, I just need to find the number of people in B complement divided by the number of people in my entire set. So my entire set here is A. That's where I'm drawing people from. So the number of people in B complement is 4. The number of people in the entire set was 6. So that probability is 4 over 6, or we can reduce that down to 2 over 3. Okay, so let's go ahead and move on to this last probability. I'm going to give us a little bit of space here first. I'm just going to rewrite are left-handed and live in California. If I spell it right. And then I can get rid of that. So I can have this nice amount of space here. Alright, thanks for staying with me through that. So let's go ahead and think about the probability that we have B given C. So first let's write this out in words. So this is the probability that B, so someone in my family, is left-handed given that C is true. So given that they live in California. So when I'm doing this, I only want to focus on the people who live in California. And that becomes my new sample space. So I'm only looking at Mark and Ian here because those are my 2 family members who live in California. And then I'm saying out of those 2 people, how many of them are left-handed, right? And only Ian is left-handed. So I can get that 1 out of 2. So the probability of B given C is 1 out of 2. So that's sort of the way we can think about it from the definition. We can also think about it from this algebraic formula we have. So the probability of B given C is the probability of B and C divided by the probability of C. Or we can think of it as the number of B and C over the number of C. Right, so sort of moving bottom to top, the bottom way is what I just thought about, to be B and C. That's the number of people in the intersection. There was only one person there. The number of people in C, those were the 2 people who lived in California, so I could get that 1/2. Or, moving up, I can do it in terms of probabilities. The probability of B and C is the number of people in B and C, which is 1, over the number of people in my family, so 6, and divided by the probability of C, which is 2 total people in C, out of that 6. But dividing by the fraction is the same as multiplying by the reciprocal, and then these 2 6's should cancel, and we end up getting that 1/2. So we can think of this, oops, I wrote 1/4. We can think of this a lot of different ways, and we'll always get that same answer. So far, we've been working with this Venn diagram where I've listed out the names of all of the people in the different regions of this Venn diagram. So maybe instead what I would want to do was actually list the number of people in each thing, right? So when I'm doing probabilities, I don't really care who is in each set. I just want to know how many people are in each set. So I want to go ahead and redraw this Venn diagram where instead of thinking about a number, or instead of thinking about the people themselves, I just want to think about the number of people in each of the different regions. So I'm going to go ahead and just redraw. This will be my set B. This is my set C. And now I just need to count to figure out how many people are in each of these different things. So inside B, but not C, is just my dad. So that's only one person. So there's 1 there. Inside the intersection, in both B and C, there's 1. And then inside C, but not B, there's 1. And then if I look on the outside, I have 3. So now from this Venn diagram, I can still determine all of those probabilities, but I don't know exactly who is in which region of the set. Okay, so let's say we have one extra set here. So let's say I have the set D, and it's going to be the people in my family who were born in New Jersey. I'm not going to tell you who those people are yet, and I want to see if we can figure out what type of information we need to be able to know the number of people in set D and the number of people in all of the overlaps of D with other sets. So I want to go ahead and draw my Venn diagram I had before, and then we'll throw in our set D. Let's pick a good color for that one. Make that, we'll just make it yellow. So this is my set D. And I need to know sort of what numbers I could tell you so that you could fill out the numbers in this chart. So far, I know between these two, there's 1. Between these two, there's 1. And between these two, there's 1. Right, so because that 1 can't be split, it can't be a half and a half, I have to tell you where that person is. And if I don't tell you, then you won't be able to figure it out. I also need to know how many people are here, right? Because I have this 3, and this 3 has to be split between these 2 regions. So that's the same as saying, you know, if I think back to my labeled diagram, here's my dad, and I have to tell you whether or not he was born in New Jersey, because if you don't know, there's no way you could figure that out. So let's say I say dad was born in New York. So that's telling you that he wasn't born in New Jersey. So I could also say that B intersect, sorry, I didn't draw B. B intersect D intersect C complement. So let's think about what that means. So B intersect D is the region between B and D. So that's both of these 2 regions here. And then C complement means you're outside of C. So that's just this region right here. So if my dad was born in New York, he's not going to be in that New Jersey set. So that's telling you that this region right here has to be 0. So that must be 0. Sorry about that. That must be 0. And that means that this over here must be 1. So I've taken care of that 1 that needed to be split between the 2. Okay, so what else would I need to tell you? Well, I need to tell you if this 1 in the middle here, so that represented Ian, if he was in which of those 2 sets. So, I can tell you that. Ian was born in New Jersey. Actually, let's go ahead and do this. All my brothers were born in New Jersey. So maybe you don't remember who my brothers were, but that was Brian and Mark and Ian. So that's actually 3 pieces of information. I've told you that Ian was born in New Jersey, so he needs to move down into this set that's both New Jersey, left-handed, and California, which means there's no people who are left-handed California and not New Jersey. Mark was also born in New Jersey, so he moves into this intersection. So he is in New Jersey and California, but not left-handed. Oh, sorry, I showed 0, but I meant to say a 1. Let's fix that. I was thinking of a person that I was drawing, but that's not what I'm doing. I'm drawing numbers. Okay, so that's Mark moving into the New Jersey category, so there's 0 people out here. And then Brian was born in New Jersey as well, so he is in here. But I didn't tell you what about my mom, right? So we don't know where she is. Turns out she was also born in New Jersey. So now, that's 2. So we'll have 2 people out here. Jimmy was not. Jimmy was born in California. So he is outside there. So with those pieces of information, we can kind of start figuring out where all of these different pieces should go.